Welcome back to Prep 8. So in this example, Campus Coffee House wants to determine if the average amount of money students spend per visit differs from the national average for campus coffee shops. The national average amount spent per visit is $7.50 with a known standard deviation of $1.20. The coffee house randomly samples 30 transactions from students and records the amount spent per visit. At the 0.05 level of significance, they want to test if their average amount spent per visit is different from the national average. So different, remember, means two-tailed test. The distribution is Z in this entire unit. The null hypothesis is that there's no significant difference between the visit spend, and the national mu. And the alternative is that there is a significant difference, because right now we don't know which way. We don't know if we're better, we don't know if we're worse. We hope to find out. By the way, we have one other graph over here, which is always nice to look at. Again, we're trying to give you as many images as possible. So really what happens when you fail to reject the null hypothesis, what you're effectively saying is that the sample could fit inside of the sampling distribution. In other words, it could reasonably be a sample from the population. And when you reject the null, you're saying, hey, no, the sample actually belongs to a different population. So let's see what's going to happen here. All right, so let's calculate our X bar. It can be the average of all these guys over here. Standard deviation, and the count. And then the national numbers from the problem are 750, and the standard deviation is $1.20. Okay, so here we are. Here's the national. Those actually look pretty close, so we'll see if there is a significant difference. So the mean of the sampling distribution is always the same as the population mean, and then the standard error is going to be sigma from the population divided by the square root of the sample size. All right. So real quick, does it make the eye test? And the eye test is that, here's the sampling distribution. We are within one standard error, right? Because from here to here is one standard error. We're within one standard error of the mean of the sampling distribution. So this is probably not going to be a reject. This is going to be a fail to reject in all likelihood, but let's see. So we take our visit spend minus the national, and then take the observed difference, which we just calculated, divided by the standard error, and then calculate the probability. Right, so here's the probability. We have a positive number and a two-tailed test. So let's see what happens when we have a two-tailed test, positive number. It ends up being 2 times 1 minus norm.dist, so 2 times 1 minus norm.s.dist of that z, comma, true. So probability is 38% that we would find this value. That's pretty high. That almost for sure means we're going to fail to reject. But let's be scientific. So our alpha is 5%. Now we can see for sure we are outside the rejection region. And then let's finish this off. So remember, this is norm.s.inverse of this number, and calculate it across, and then for this one, we do the 1 minus when we're dealing with the right tail. And remember I told you earlier sort of 2 is the magic number. Actually, it's 1.96, but 2 is easier to remember. So if you see 1.96, that's a good one to remember. Very close to 2, as far as like if you're more than that, it's probably a reject. Okay, let's get the x bar, and then subtract from the x bar the standard error times, and we always pick the 2-tailed right value of the critical value z-score, effectively. And then over here, do the same thing, but add it this time, plus. All right, now, this is really interesting. The confidence interval includes our mean, but it also includes the original population mean. That's even more evidence that this is a fail to reject. If your confidence interval includes population mean, then there's no way you can reject the null hypothesis. So this is all fail to reject. We got so many data points about why this is a fail to reject now. So we're going to fail to reject the null. And the problem is that our p-value is much greater than alpha, which means they probably came from the same population. And we're less extreme than the critical value, right? 0.87 is less extreme than 1.96, so we're less extreme than the critical value. We're closer to 0. And so the conclusion is that there is no significant difference, right? We failed to reject the null. And the caveat is that we might be committing a type 2 error. In other words, we might be failing to reject the null when in fact it is actually false, but we're going to take that chance, and we're feeling pretty good about it. All right, what does the result of this 2-tailed z-test indicate about the campus coffee pricing compared to the national average? Just no significant difference. All right, so let's look at the numbers, right? Basically, we're saying there's no significant difference between 7.5 and 7.69. That's not a big enough difference for it to be significant. Now, part of that is influenced by the sample size. So watch what happens. I mean, just for grants, let's say I change that sample size to 3,000 instead of 30. A lot of samples, right? Right. What would happen is that the z-score would get ratcheted way up, and the probability would go to 0. This would actually become a reject. In other words, if your sample size increases a lot, then even minor differences can be detected. And sorry about these graphs being all scrunched up. But even minor differences will be detected. So let me undo that. But of course, if the sample size went to 3,000, then I would also get a much more accurate value of x bar, and maybe the much more accurate value would be closer to 7.5. So maybe it'd be a fail to reject. So, you never know, right? You never know exactly what's going to happen. All right. So the alternative hypothesis is non-directional in a 2-tailed test. However, if we reject, it has direction. So which is true in this particular case? The alternative is that they were not equal, but the conclusion is that, in fact, they are equal. If the confidence interval includes H0, what can we conclude? That we failed to reject. That's actually what happened to us, so we're going to fail to reject. And in this example, the upper bound of the confidence interval corresponds to what type of error? Well, that's kind of an interesting question. The upper bound of the confidence interval corresponds to what kind of error? Well, look where the upper bound is. The upper bound would actually be in the rejection region. So it corresponds to, what did we say? A type 2 error. right, failing to reject the null hypothesis was actually true, because the upper bound means that, well, we could have gotten a sample out here, right? And for a z-test, does the height of the red dot matter in the first graph? And we already said no, because the sample standard deviation is not used to calculate the standard error. We said that in the last problem. And we're all done. We got all our points. We'll see you in the next video.